Challenge day number one. Let's take a look at these. All right, number one. Angle ABC is congruent to angle CBA illustrates what property? Now, we know this is going to be one of those special properties, right? This isn't just like the normal addition, subtraction, substitution, distributive property type of properties, but this is those three: the reflexive, symmetric, transitive. And I think, hopefully, you can easily tell that this is not the transitive property because it really lacks a lot of stuff that would need for it to be the transitive property. And so the most common mistake answer for this one would be the symmetric property of congruence. And the reason why this is not the symmetric property is really things are flipped around with the symmetric property. For the symmetric property, it would have to be something like this. If angle ABC is congruent to angle CBA, then angle CBA is congruent to angle ABC. That's what the symmetric property would look like. And so I tried to trick you and make this truly a challenging problem by rearranging the letters of the angle. Now, in the end, this is just one angle is congruent to one angle, and angle ABC, if you try drawing angle ABC, ABC, and angle CBA, it's the same exact angle. It's just a different way to name it. So in the end, what I'm really saying here is that this angle is congruent to itself. So this is a tricky way of illustrating the reflexive property of congruency. Now, keep in mind, since this does say congruent, this needs to be a PC and not a PE as well. So there's the other little tricky part in there. All right, number two, a kind of proof that's already kind of filled out most of the way. We just need to fill in 4 blanks. All right, so first line, angle 1 is congruent to angle 3. And that was simply given to us, right? So there's our first line that we've got the given information right here. So then they jump in and they say angle 1 is equal to angle 2. Okay, so why do I know angle 1 is equal to angle 2? Let's go look at the picture. Angle 1, angle 2, those are vertical angles. And we had stated before that all vertical angles are equal or congruent to each other by the vertical angles theorem. Okay, so now the next line, we got to figure out what is going on here, but we're using the transitive property somehow. So if I'm using the transitive property, that's my clue. We're probably going to be combining the last two things. And so if angle 1 equals angle 3, and angle 1 also equals angle 2, well, angle 1 is that common connector, and what they connect to is what I can now claim as being true. So if 1 is equal to 3 and 1 is equal to 2, then 2 is equal to 3 by the transitive property. All right, so now the next line, we got to figure out what goes here, but they're using the vertical angles theorem. Now, would it make any sense to just rewrite angle 1 equals angle 2 by the vertical angles theorem? And it wouldn't, because we've already talked about it. We don't have to write it again. So there must be some more vertical angles. And so if I look back up here, hey, I do see some more vertical angles. Angles 3 and 4 are equal to each other. And so now I see what I need to prove is that angle 2 and angle 4 are equal to each other, but how do I get to that point, right? What's the reason that's going to allow me to conclude that angles 2 and 4 are equal? And really, it's those last two pieces of information. If angle 2 is equal to angle 3, and angle 3 is equal to angle 4, then using those two things, we get to conclude this, that angle 2 is equal to angle 4 by the transitive property of equality. And so there's number 2. Number 3, solve for x using the given information right here and justify each step. So this is going to be kind of like that practice worksheet that we did before, where we see some algebra stuff in here, right? And we're being told to solve for x, but first we're going to have to talk about some geometric stuff, all right? So in our given, I won't be lazy here. I'll write it back out. QR is congruent to PQ, and RS, I can just separate this with a comma, or you can put this down on the next line, completely up to you. So there's my given. So QR, segment QR, here's segment QR, is congruent to segment PQ. So I can put one congruent marking, one congruent marking. And I'm also told that segment RS, okay, so here's RS, is congruent to segment PQ. Well, PQ had one congruent marking on it. So it's almost like I could put still one congruent marking on PQ and one congruent marking on RS, but PQ has the same congruent marking on it. So we're going to have to somehow pull together this whole connection with PQ with QR and PQ with RS. Okay, so here's that first real geometric thing we need to discuss. If QR is congruent to PQ and PQ is congruent to RS, then there's that common connector PQ. What must be true is that these other two pieces must be equal to each other. So QR is congruent to RS. And there's using the good old transitive property. Now here's the deal. I've been using congruent symbols all this way, so technically this is the transitive property of congruency. Now, the only time I would let you use transitive PE is if you had already converted all of these congruent signs to equal signs. All right, that's the only time you could then say transitive PE. Now we're going to get to make our substitution. So QR has a value of 2x plus 5. And now here's where I'm just going to convert the congruent sign to an equal sign. RS has a value of 10 minus 3x. So there we're using good old substitution property of equality, because now we have our equation that we're going to solve. Let's add the 3x over to the other side. So now we have 5x plus 5 equals 10. There was our addition property of equality. Let's subtract our 5 over to our 10 to get 5x equals 5. Subtraction property of equality. And last but not least, divide the 5 over to the 5 to get x equals 1 by the division property of equality. So there we go. We solve for x and we justified each step along the way. And the last one. So this one's going to be full-on proof, and we're going to have to write this thing out. There's no solving for x in this one, like in the previous one. So let's save ourselves a little bit of time. Let's just take this. Let's drop it down here. Boop, put it on a line. There's our given. Now notice we've got a vocabulary word in our given. So we're going to need to talk about what does complement mean, or complementary mean specifically. And we're also told that angles 2 and 3 are congruent to each other. So I could simply go ahead and mark angles 2 and 3 with congruent markings in the picture. Okay? So let's go ahead and talk about that vocabulary word. That angle 1 is a complement of angle 2. So angle 1 plus angle 2 equals 90 degrees. And we knew that was true because of that vocabulary word complement, or I'll just leave it as C-O-M-P. And so we know that they add up to be 90. Now, looking ahead here, we need to prove that 1 and 3 are complementary angles. Well, I know that 1 and 2 are complementary, that they add up to be 90. And hey, this is where that other piece of information is now going to kick in, right? We know that 2 and 3 are equal or congruent to each other. So let's make that little substitution out. So instead of angle 2, we substitute it out with angle 3. So there's substitution property of equality. Now again, this is where people might stop and go, hey, done, we've shown that they're complementary, they add up to be 90, but literally whatever the proof statement says, that needs to be the last line. So this is that little baby step we got to kick in here. We see the word complement being used here, right? So now we just need to go ahead and say, well, angle 1 and angle 3, or you could literally, here, let's just do it that way. Angle 1 is a complement of angle 3, aka angle 1 and angle 3 are complementary. I would be okay with that still. Okay. Now, how do I know that angle 1 and angle 3 are complements of each other? Well, based on this previous line that angles 1 and 3 add up to be 90. So here I'm introducing the vocabulary word, so it's still definition of complementary. And then we're done. So that one was a pretty short proof, but again, you kind of had to see how all those weird puzzle pieces fit together. So that is all for challenge day number 1. We have a quiz coming up very, very soon.